Okay, we're going to go over second differences here. Second differences deal with or talk about quadratic relations specifically. We have a table, and they've given us x and y values, essentially coordinates. We need to determine from this table whether this is a linear equation or a quadratic. Okay? And we're going to talk about what quadratic is. If you guys remember yesterday, we briefly showed that. We'll get into depth. So, what we do to figure out what type of relationship this is we find the differences. When we do the first set, we call them the first differences. We find the differences of the y values. Okay? So these are all of our y values. In order for this to work, we have to make sure first that our x values are increasing or changing by the same amount. If you guys look, these are each increasing by 1. That means we can actually use this chart in order to do this. If they were not increasing by the same amount, we couldn't use this method to solve whether something is linear, quadratic, or neither. Okay, so first difference is, well, that is when we take the second term, second y value, and subtract the first y value. Right? So we take the one below, we have 1, and we're going to subtract 4. What do we get? -3. Good. All right, so that's the first pair. Second pair, we take 0, subtract 1, what do we get? -1. Oops, that's a 2. -1. We then do the next one, next pair, 1 subtract 0, what do we get? And we then take 4, subtract 1, 3. Okay. Now, we look at what our answers are, and if you notice, our answers are all different terms. -3, -1, 1, and 3. They're not the same. We're looking for answers that are the same. Had these answers been the same, for instance, let's hypothetically say that these were all the number 2 for some reason, then this would be a linear equation. In other words, it would form a straight line on a graph. Okay? But because they're not the same, we have to test to see if it's possibly quadratic. Second differences will let us know if something is quadratic. Okay. So we do the same method, but in this case we use the answers we got in the first one. So we take the -1 and the -3. -1 subtract -3. What's that going to give us? +2. Our next pairing is 1 subtract -1. What do we get? No, 2. And then we take our next term, 3 subtract 1. What do we get? 2. So, all of these were the same. Because all of them are the same, that means we have a quadratic relationship. So, if second differences are all the same terms, assuming it's not 0, they're quadratic. If first differences are all the same, that means it's linear. And if none of them are the same, well then it's neither linear or quadratic. Okay? So, now that we know how to tell by looking at a table whether something is linear or quadratic, let's actually talk about what that means. Okay, we're going to go on a graph here. Now, quadratic relationship, if you guys notice, we have ax squared plus bx plus c. This trinomial is a quadratic because we have a variable that is to the power of 2. So all that factoring we were doing before, we were actually working with quadratic expressions. They're going to look like, and in fact what we'll do is we'll plot those points that we had above. So -2, 4, -1, 0, 1, 4. Okay, we're going to plot those points to see what this relationship would look like on a graph. So we had -2 and 4, -1 and 1, 0 and 0, 1 and 1, and 2 and 4. Well, what that means is we have a relationship that forms this. This is a quadratic relationship. Okay? The shape of this on a graph is called a parabola. Okay, so this shape is called a parabola. There are many parts of this quadratic relationship or parabola that we have to get used to looking at and knowing how to define them. So, the lowest point on a parabola or a quadratic is known as the vertex. Okay. In this case, what is the vertex? What's the coordinate? 0, 0. Good. This is important. Okay? The vertex is at 0, 0. Now, because this quadratic or this parabola opens upwards, this is the lowest point. Okay? The lowest point, if it opens upward, is known as the minimum. Okay? And the minimum deals with the y value. What's the highest or lowest y value? Well, because this is a minimum, what is the lowest y value? Well, what's the vertex's y value? Yeah, not 0, 0, just 0. Okay? So the minimum would be y is equal to 0. That would be the lowest point that this graph would hit. Everything else would be above that. Now the vertex tells you that. The y value of the vertex is the minimum. Another part of a quadratic that's very important is called the axis of symmetry. The axis of symmetry is an imaginary line. I want it to be dotted here. Okay? It's an imaginary line that runs through the middle of the parabola. It just so happens this one is on the y-axis, but that's the direct middle of the parabola. The axis of symmetry, we call it sometimes the AOS, axis of symmetry. Okay. The axis of symmetry is what the x value of the vertex is. So what is the x value of this vertex? 0. So the axis of symmetry, or the AOS in this case, is x is equal to 0. And AOS is always a vertical line, cutting right through the middle of it, so that the parabola is symmetrical on both sides of this axis of symmetry. Okay? Talks about minimum vertex. Okay, so let's say I have another type of parabola. For argument's sake, I'm going to draw one that is here. Okay? This. Okay. Try to make it so it's a realistic parabola. They're not all exactly the same shape, and we're going to learn the pattern of how to draw one. Okay? Now, where would the vertex be in this specific parabola right now? Where would the vertex be? What's the coordinate? -7 and 8. The vertex is the highest or lowest point. Okay? Because this parabola opens downwards, the vertex is the highest point. Okay? Because it's the highest point, it's not known as a minimum. What would it probably be known as? A maximum. This is the max value of this parabola. Okay? So it depends whether the parabola is opening upwards or downwards in regards to whether it has a maximum or a minimum. What would the maximum value of this be? Y is equal to what? 8. Exactly. That's the highest y value that this parabola would touch, that this line would touch. The axis of symmetry, in this case, let's get an axis of symmetry, this one that's green, is going to run right through the middle. What would the AOS, or axis of symmetry, be of this parabola? X is equal to -7. And both those answers are found in the vertex, right? -7 is our axis of symmetry. Our max or min value is the y value. In this case, it's a max of 8. Okay? I think that's pretty much it. So, we pretty much went over quadratic relationships. One of the important things we needed to know is if we're given a table and not a graph, okay, so we haven't been given the graph, let's say. If we're given a table, to tell if it's linear or quadratic, we find first or second differences. This tells us all of the information we need to know about the new type of relationship we're going to be graphing. Before, we only did lines, linear relationships. Now we're going to be working with lines and quadratics, or parabolas.